is. Okay, cool. Now I'm recording. So for the most part, this is just helpful for us to keep track of who's coming and stuff like that. Please use that Piazza link to check in. That would be super helpful. Today's going to be a special programming team lecture. For our meeting today, I wanted to talk about the technical interview. So this is a little bit different than what we've done before. And one of the highlights of this is I get to embarrass myself because Sam before this actually did a technical interview with me. It was like a question that I've seen before, but it wasn't a question that I had the answers in front of me or anything. It was just a live question. I tried to answer it. I ran into bugs and stuff like that, and I fixed those bugs. So it's going to be slightly different just because you can actually see what it looks like when someone else is doing a mock interview. And then after we do that mock interview, after you see some of the tips and tricks that I used, you can learn from my mistakes. And as you see what I did well and what I didn't do well, you can learn from that and figure out what that looks like in practice. Now in week 1, I told you about what to do for the technical interview, but I actually wanted to show you what that looks like in person. So a couple of agendas. We have some updates and announcements. We have some interview tips from me, then a live interview from me, and some practice mock interviews for you. So again, sign in here. Couple cool things. We're gonna have a cross-college contest. Right now we have anywhere between 3 and 7 different colleges who are interested. So this could be a lot of different colleges across the US who are participating, and we're gonna be hosting them virtually, of course. But we're gonna be hosting a competition for everyone. We just came up with the name of the competition earlier today. Sreya, do you wanna say what it is in the chat? Because I'm very excited about the name of our competition. It's going to be Saturday, November 21st from, let me get the dates, the times on here, 1 p.m. to 5 p.m. EST. Yeah, and our competition is called Cran Binary Sauce and Hashed Potatoes, a Thanksgiving or a Texgiving programming competition. So get pumped. It's going to be fun. It's going to be full of puns because I am going to be organizing it and I like my puns. So make sure you come. It's going to be a lot of fun. There's going to be some small prizes as well. Make sure to sign up for Caddis too. So if you just go to Caddis and sign up there, it's going to be important that you do that. Cool. So one thing that we've discussed is that one of the hardest things about interviews is that you have to do a lot in just 45 minutes. Sometimes you even need to answer 2 questions. Like if you do an interview with me at Facebook, you have to answer 2 questions in 45 minutes. That only leaves you like maximum 20 minutes per question. So how do we actually do it? That's what we're going to talk about today. So if you haven't already, take a look at what we covered in week 1. But what we covered was actually high level. What does that look like? Before I keep going, anybody have thoughts on how to do well on a technical interview? Like, what are some good tips to know? Sure. Well, okay, so we have the knowing algorithm side. That's obvious. We have to know our stuff. Otherwise, we won't pass our interviews. What else? Yeah, so some people are saying be a good communicator. What does that mean? Christian hinted that we want to ask clarifying questions. That's a great point. You want to make sure you understand the question. Then Jason mentioned that we want to be honest. So be honest about what you know and don't know. Sure, absolutely. Make sure to go over code. So yeah, once you've written your code, make sure you actually know that your code is working. Learn about the company, probably less important, honestly. Learning about the company is cool, but that's just kind of like for yourself more than it is to like impress an interviewer. Knowing a projects on your resume, that's for a behavioral interview, which is a different thing, absolutely. And then having some test cases in mind, absolutely. You want to take some test cases before you start coding and make sure that you know what that looks like. Cool. You got everything that I'm going to cover in class during our programming team today. So I'm actually going to skip the next 15 slides and we're just going to go ahead and work together now. Just kidding. I'm actually going to show you what this looks like. But yes, you did actually cover everything that I was going to cover. But I want to show you what that actually looks like. So I broke it down into a before, during, and after. So before you start coding, make sure you do the following. Make sure you ask clarifying questions and write down your assumptions. That is super important. Then you want to run through your examples, and then you want to write out your algorithm. So my first question is, why do we want to ask clarifying questions? Isn't that a waste of time when we could just start coding? Y'all got anything? Return values and input types, sure. So you want to make sure that you're engineering your solution to the actual inputs and the return values you want. You don't want to over-engineer it and you don't want to under-engineer it. So asking clarifying questions is going to help with that. Find out what the problem is actually asking, and then you can start figuring out a solution from there. Sometimes they're intentionally vague. I am intentionally vague all the time. I do that on purpose to test whether people are asking clarifying questions correctly. Asking clarifying questions is important so that you're solving the right question. Absolutely. So let's see how I did that. So this is how today's thing is going to go. I took a literal live like mock interview that I did with Sam. And here are actual components where I'm doing these things. I'm not doing these perfectly. I'm not like an amazing interviewer or anything. I don't pride myself as being like the guy who does great at interviews. But here's me actually doing that. And I'm going to share that for a sec. Let me just ask you some clarifying questions, make sure I understand correctly. Oh, perfect. You're giving me some examples. Cool. Yep. So we have, oh, before I go, go ahead and read that question. The question is basically two-sum. Given an array of numbers and an integer target, return the indices of two numbers such that they add up to target. And then you can assume each input has exactly one solution, and you may not use the same element twice. Some numbers, we have an array of numbers. Each of these is distinct, it looks like. Oh, actually, it doesn't say that. Can we assume the numbers are distinct?
No, it's possible to have duplicate numbers.
Okay, cool. Oh, I see, like three.
That's this test case here.
Got it. Sounds good. Okay, and then basically what we're going to do is try to find two numbers that add up to that number. So in the case of 9 here, we want 2 plus 7. The case of 6, we'd want 2 plus 4. Got it. And then we want to return the indices. My question for you is, one question I had is, let's say we had something like this. Would we want to return like an array of arrays or just one of them?
Well, in this case, you can assume that the input is only going to have one solution.
Okay, sounds good. Oh, it does say, okay. So here's me fucking up a little bit. It was very clearly worded in the actual question that I should only have exactly one solution, but I didn't read it very carefully. So don't do what I did there where you don't actually read it properly. Okay, sorry, I didn't read the question.
No, it's good.
Okay, sounds good. You can return the answer in any order. Sounds good. Okay, so can we assume that they're all positive numbers, or can they be negative numbers as well?
They can be negative as well.
Okay, sounds good. Okay. All right, so my first thought about this, so I'm going to write some like algorithms, like some idea of what I want to do here. So before I do that, I want to write my assumptions down. So So this is super important. I asked him a bunch of questions, but before I start coding, I'm going to actually write down my assumptions, because if you don't write something on that piece of paper, it doesn't count. So let's say that Sam thought that he specified that it was only positive numbers, but I misheard him and I said that it could be negative numbers. Now, I want to clarify that before I start coding, and that's why I'm going to write it down. And have negative numbers. May have duplicates, but can't use the same index twice.
Correct.
And then the last thing that I wanted to say is these are all valid integers, right? I don't have to do any like error handling to figure out if there's that. Okay, all
You can assume your input is proper.
Okay. And then there's exactly one proper solution. So there's no case where there's no solution. Does that sound good?
Yeah, those assumptions are fine.
Let me just ask you some clarification questions, make sure I am. Cool. So now I have a question for all of you. So Mike, we don't, that doesn't matter. It doesn't matter that it can be solved in O of n time with space complexity. The more important thing at this point is figuring out the communication. We don't want to jump to that solution right now. We want to actually work through the process right now. So what I want you to do is really quickly, can you guys reflect on what I might have done differently there than what you're used to doing during a technical interview or a mock interview? Any thoughts on what I did differently? Not necessarily better or worse, but just differently than what you usually do. Right, so actually writing out the assumptions. Yep, this is really important. You want to document everything because you want to make sure that you're actually going through and documenting that this is a this is a conversation that I had with the interviewer. What else? Anything else? The input is sorted or unsorted? Sure, I asked some clarifying questions about what the input looks like. Anything else? So let me tell you one thing that I think I did differently here than what other people I've interviewed at Facebook or at NJIT do. So the piece of paper is definitely collected at the end of the interview. That is the only thing that matters really. So at the end of each interview that I do, I take a picture of the whiteboard, or I just take a screenshot of the Google Doc that I'm interviewing in. That's how I actually grade people and assess whether they passed or not. So if you don't put everything in writing down, then it doesn't matter. It doesn't count towards your final, towards your final evaluation. So absolutely, you have to write everything down. The other thing that I wanted to mention that I do that other people at NJIT generally don't do is I try to have an open conversation with Sam. So like Sam and I were talking that entire time. I would ask him a question, ask him if it's okay, keep going. Next minute, I would ask him another question, say, does that sound good? And I would get his feedback over and over, probably once or twice every like 5 minutes. I would be asking for his feedback and asking if I'm on the right track. That way I'm never spending like 5 minutes or something where like I'm just going down the wrong path. Why is it bad if you misread a question and ask a question that fixes your misconception? It's not. That's a good thing. If you ask questions that fix your misconceptions, that's awesome. That's a really good thing that you are doing. Cool. So I'm going to go into my next tip now, which is, yeah, as long as you do it before you code, that's fine. If you do it after you code, that means that you didn't communicate your requirements properly. Tip 2 is going to be running through your examples. So figure out if your interpretation is correct by running through an example. So let's go ahead and go over that really quickly. Keep in mind that all of these demos are like 2 minutes long. So like I'm doing this very quickly. I'm not taking like a ridiculous amount of time to do these. I'm running through them quickly, but not in a rushed way necessarily. So let's actually run through an example. I think that would be helpful.
Yeah, go for it.
So I'm going to take this example 2 that we had, and I'm just going to copy and paste it down here. So given that we have something like this, I was thinking that we just store something like 3, 0 as a tuple, and then 2, 1, and then 4, 2, something like that. Or we could do what you were saying, where we do a dictionary, and then now it's just a key value pair that looks something like this. And this would also work. The one reason that I was thinking of storing tuples as a set is just because we have a case like example 3, where we have 3, 3. So like that could be a little problematic where like if we have two keys with three, we might have a collision. So we'd actually have to store something like that, which can get a little bit messy. Whereas in this solution, we could easily store, 3, 1 as well without any collisions.
Um, well, just one question. How are you going to check if, like, say this is your example, right? When you're at 2, how are you going to check if target minus array current index is in the set?
Good question, actually. Given that like we would have to actually check for each of these, that's a good point. So it looks like we would actually have to be doing a key value pair the way that you mentioned. Because the thing that you mentioned was basically like we won't be able to check in constant time if 3 exists in here.
Exactly.
That sounds right to me. So maybe instead of doing that, we'll do something like this. And then we'll just have an array inside of here, and then that array will contain all the indices. Does that sound okay?
That seems reasonable.
Cool. What about that time? What was different about that time? And like, what did I do differently than maybe you would have done? Yeah, so I mean, I technically wrote my algorithm right first and then ran the test cases. I sort of considered the edge cases, but not that much. I sort of did, yeah. But yes, I did write my test cases first-ish before I actually wrote my code. Absolutely. And again, another thing here is I communicated. I asked Sam if that's okay. I asked my interviewer like, hey, does this look okay? Or should we do something different? And I missed a bug, right? Sam pointed out like, hey, I don't think this is going to work. And then he was able to point that out to me and I was like, oh, interesting. This is actually not the right way to do this. And this wasn't me acting or anything like that. It was literally just me being like, oh, shoot, I literally messed up. And he taught me how I could make it better. Now, one question for you, is it good or bad that I messed up? Like, is it good or bad that I made a mistake there? I wouldn't say necessarily that it's good that I made a mistake, but one thing is that I didn't catch the mistake, but Sam hinted towards why it's problematic. So I'd say, yeah, what Mike said, it's fine. It's not like a bad thing necessarily. It's not going to ding me generally. It's more of just like, oh, he was able to figure out why this is problematic without like me telling him why it was problematic. So that's probably what I would write down in my interview feedback. I'd be like, he made a mistake, but then I pointed it out and he figured out why it would be problematic to do that. And then giving myself multiple outs in order to do it in a different way helps me make that case. So the tip number 3 that I have, and this is probably one of the most important ones, is you absolutely, oh, I'm not screen sharing, sorry. The third tip that I have is you absolutely must write pseudocode to write an algorithm. You do not want to write real code until you are confident that your code will work. So spend a lot of time making sure your pseudocode works instead of spending a lot of time just debugging actual issues in your code. Ask if your pseudocode is good, and if it's not, then you can go back to the drawing board. So here's an example of me doing that. Okay, so let's talk about the algorithm. The way that I'm thinking about this is basically if we have some number, like let's say basically we're trying to figure out a solution to a plus b equals target, where a and b are both in our array. Mm-hmm. So the brute force way that I can think about doing this is basically we do a double for loop. So we do a for loop for each in array, and then we say for each 2 in array. Just figure out basically if each plus each 2 equals target, then return their indices, something like that. Now the problem that I see here is that this is going to be an O of n squared solution where n is the size of our array.
Right.
The reason being that we're iterating twice. Is an n
Do you,
squared solution okay, or should we iterate further on that?
I think it's possible to do better. Do you have any ideas?
So I know that n squared isn't great, right? But I did want to ask him if that's okay or if we can do better. Before I waste any more time, maybe Sam's just like, hey, this is a warm-up question, n squared is fine. In which case, I'm just gonna go ahead and do the n squared solution. Yeah, so one idea that I was thinking about is, well, I guess one question I wanted to ask you is, I see here that the second test case isn't sorted. So we can assume that this test case isn't sorted or anything, right?
You can't make any assumptions about sorting. They'll be passed in random order.
Okay. So one more idea I had was basically sort the array. So this is going to be an O of n log n n like method. We can just use merge sort or something like that. And then once we've sorted it, we can do like a binary search or something like that. So basically you have for each element, so basically you can do for each an array, now do a binary search for target minus each. So now this is an O of n, and then this is an O of log n. Do you follow why, should I explain why this is O of log n or anything like that?
Well, binary search, that's pretty well defined as log n.
Mm-hmm.
So I think you can gloss over that for now.
Yep. So this looks like O of n log n, but I do actually think that by using extra space, we might be able to get this to linear time. Would it be okay if I use that extra space?
Yeah, go for it. Let's see what you think.
So we have, this is, so I'm going to make some remarks here. O of n log n. This looks like it's O of n squared. And then the last algorithm that I was thinking about is, let's just think about a linear time algorithm where we have O of n. And the way that I'm going to try doing this is actually store each element in a set. And I'll talk about the indices later. That's just a small complication that we can easily handle. But basically, we can store each element in the set, and then basically do for each an array. If this basically if target minus each is in set, let's just say return something here. I'll just put a to do in here, and then we can figure out what to return.
Sounds good.
So right here, this is going to be an O of n time, O of n space. And then this is going to be an O of n iteration. And then this is cool because hash sets actually use hashing logic. So this is a constant time amortized operation.
Right.
So it looks like we're actually going to have linear time, and linear space. Of these two algorithms, which would we prefer?
I think the O of n algorithm with extra space would be pretty good.
Cool. One more time. What did I do differently than what you would have done, or what you think to do naturally? So I asked, right. So I asked which one to go with. And why is that important, Mayank? Why did I ask which one to go with instead of just assuming one of them? Right. So I'm basically asking if the time and space complexity is okay. And the reason I'm doing that is sometimes there are trade-offs. Like sometimes we're like, hey, we really don't want to use extra space, in which case the n log n solution might be the actual preference. And even that n log n solution does use some extra space because we're sorting. So we might have to actually think about whether we might have to do an n squared solution. So that's definitely something you want to think about. You don't want to just think about time. You want to think about all the trade-offs. The other thing is obviously I'm using the pseudocode. One more thing is Patrick mentioned that I lose track of the indices. That's true. But what did I do about the indices? Like what did I what did I do that you might not normally do when solving a problem like this? I mean, you could get an index of the element later from the original array, but yeah, Andrew, like I just said, I'm gonna skip it. I'm just gonna fix it later. It doesn't matter. That's just a small complication. We'll figure out what happens later. And spoilers, that does actually lead to some problems a little bit later on, but nothing too major. So we don't have to worry too much about that. But basically, you want to focus on those high level concepts. You want to focus on getting something out the door so that you're not bogged down on all of the details. So yeah, you would have derailed there. A lot of people would have derailed there. So a lot of people just go and be like, I don't get what to do with the indices. And I was just like, screw it, we'll figure it out later. If I can get 90% of the way there and then have to figure out the indices thing, then I'll just do the indices later. It's better to get 90% of the way done than 20% of the way done and get zero code written out. Let's talk about what we should do during the interview. Any tips on what we should do during the coding part? Like not the before part, but what do we do once we start coding? What are some things that we can do to make our lives a little bit easier and organize our code a little bit more? Sure, explain what you're doing. You kind of have to do it. So yeah, definitely keep talking. And now you guys are getting it. You want to communicate your thoughts. You want to definitely ask if what you're doing is okay. You want to be like, hey, I'm doing this right now. Is that okay? The other thing that I would think about, like definitely you want to keep talking, and comments could be helpful. I personally don't comment my code during interviews or anything like that. Well, I don't comment my code, period. Comments, I don't think comments are good in code to begin with. But in general, like comments, I would avoid them because instead of leaving comments, just talk about it out loud with your interviewer. And then if you have a specific thing that you want to like comment a specific line, then go for it. Instead of comments, what else can we do to convey that like some block of text is going to have some specific like role or use for it? Instead of a comment, what's a different way for us to do that? Descriptive names, sure. Variables should have descriptive names. Absolutely, I agree with that. What else? Helper methods, yes. So that is my big tip. This is very important. During the coding, use helper methods. That way you can just get the skeleton of the algorithm down and you don't have to implement everything. So stupid shit that like we don't really care to implement, like if I had merge sort used in my algorithm, Sam's probably not going to ask me to implement merge sort. He probably doesn't care that I implement merge sort as much as he cares that I get the algorithm down. So let's take a look at how I do that. Cool. Is it okay if I get started with coding it?
Yeah, let's get started.
So the first thing that I wanted to do is define the function. So I'm going to say define sum of two, or was there a name of, you didn't give me a, okay.
The name is toSum.
Okay, toSum, like this?
Yes.
Okay, so define toSum, and then we'll have a num and a target given to us. So what we want to do is, first of all, store each element in the set. So let's go ahead and say make dict of num. And then let's go ahead and say this is something like that. I don't want to call it dict because that's a reserved keyword in Python. Once we have that dictionary, we can basically just iterate through here. So we can say for I in range 0 to length of our array, so that's num. I don't like num as a variable name here. Oh, it is called nums. Okay.
I mean, you can change the variable name if you want.
Okay.
It's no big deal.
Cool. So for I in this range, we'll basically say if. So basically, let's go ahead and define a new variable. So let's say cur val equals nums I. So that's just going to take our current value and store it in that integer. And we'll just go ahead and say if target minus curval equals nums I, then let's go ahead and return, oh, wait, sorry. We don't want to do that. We want to say is in
Yeah.
DCT. Then we want to return I, comma, and then we want to return DCT of whatever target minus curval is. And since I'm using that value twice, I'm just going to pull that out into its own separate thing here. So I'm going to do something like, I'm trying to find a word for it, remainder. Let's go ahead and say that. Remainder is in there, and then we'll just go ahead and do remainder here. And this is assuming basically that we'll just return the first one, like we made that assumption earlier.
Yeah.
Cool, and then let's go ahead and implement makeDict. So basically what we're going to do inside of here is we're going to try to have the keys be the values. That's very confusing. And then the values are the index. Okay. So basically what we're going to do is for each, for I in range 0 to length of nums. So it's another for loop. So inside of here, we're basically going to say, oh, and then let's make a dictionary out here. Now I'm going to go ahead and say return DCT out here. So then we're going to say DCT of nums I equals I. I'm not sure about the syntax on Python, unfortunately. I forgot about what that looks like, but I believe this is how you do it. You basically have a key with this value, and then you assign the value for that
Yeah.
key.
That's the syntax for when you're assigning the value to be just a regular number. You were saying something about a list before, though, right?
Right. Okay. Makes sense. So let's do one thing. Thanks for pointing that out. So let's go ahead and say if dict.contains nums I, then we're going to do dict nums I. Oh, wait, sorry. If dict contains, yeah, that looks right to me. If so we're going to do append I inside of here. And then else we're going to do this logic, and then we're just going to surround this with brackets. All right, so I'm going to leave that screen share right there so that you can see my code. You could, oh, okay, so a couple things that I wanted to address out loud. People were asking, like, I was hating on Python a little bit. I'm not saying that Python is a bad language to code in for your coding interviews. I think it's one of the best languages to code in for your coding interviews if you know it pretty well. The best language to code in for your coding interviews is the one you know best. I know Java best, but Java is pretty verbose, and Python is a pretty close second for me. So I usually choose Python just because Python code is so easy to write out. It's not verbose. It's not hard to write out those things. So it's great for algorithms. That's why I chose Python for this interview, for example. That being said, like Python can lead to errors in real software engineering because it's not strongly typed. So for example, you could say dict equals curly braces, and then on the next line, you could say dict equals string high, and it's going to be fine with that. It's not going to complain about that. I think that's crazy. But that's not going to come up very often during interviews, so it's not a big deal. You can ask if you want to use Python before starting. I've never had a single person ever question my choice for a common language. I'd say the common languages are Java, C++, Python, Objective-C, and C#. All of those languages seem pretty reasonable to use, and like it doesn't really matter that you use one of those. You don't really have to ask most of the time. I've only had one person ever not use one of those 5 languages, and that one person coded in Scala, I think. And I was just like, I don't know what's going on, but I figured it out pretty much. That's an interesting way of saying Scratch, right? um, cool. So my follow-up questions about this part was, what did I do here that was different? Again, like same question as usual. What was different about my approach than what you might normally do? And again, don't focus too much on like the correctness of the code. Focus on the process behind what I'm doing. No thoughts. Um, yeah, so it's a pretty straightforward, obviously this is elite code easy, not that hard of a question. But yeah, I do put that helper method in. And the reason I'm doing that is because that makes dict, maybe Sam doesn't care about that. What I really should have done here, and I do this a little bit later for threesome, which is Sam's next question, is I make a helper method and I'm just like, okay, I need to implement this? It's pretty straightforward. And then Sam is like, nah, you don't have to implement that. I get it. So it's fine. Um, but it is n squared. What is n squared? Is there something that's n squared? There shouldn't be. Yeah, it shouldn't be n squared. Okay. And then Rashmi mentioned that I don't remember the exact syntax, and I just asked him. I was like, "Does that matter? Can you confirm yes or no? Does it matter that it's not the right syntax?" And Sam was like, "Either I don't care, or he confirmed that it is the right syntax." So again, it's okay to ask questions and say that you don't know certain things. That's totally fine too. And then the last point that I have is I forgot what the last point I have is, but let's talk about it. Oh, right. So after you're done coding, so you've made your helper methods, you've implemented whatever you've been told to do. The biggest mistake that I've seen NJIT students make is saying, yeah, and I'm pretty sure this will work. And then you just stop talking and then you just walk out the door and you're like, I aced that interview. That went so well. I wrote the code and it works and I am amazing. That is how you fail an interview. What you should do instead is run through your test cases and then find and fix your bugs. So make sure you're just actually going through those test cases you had earlier and running through them. So make sure you're reading through your code instead of assuming it works. So actually see what's happening to your test cases instead of being like, oh, I'm pretty sure this will work for this test case. Let me just run through it to pretend I'm actually doing it. You're not going to fool anyone. You actually have to run through your code because you want to find the bugs. Um, one thing I want to point out is if you are actually finding your own bugs, you get the points for that. You get credit for being like, oh, cool, he ran through a test case and he found his own bugs. Whereas if, for example, Sam found my bugs for me, then Sam gets the credit for it. And it's going to look bad on me. It's going to be like, oh, wow, Sam has to find this dude's bugs. And in industry, that's not a good sign. If you just write code and put it out there and other people have to find your bugs. So that's what we'd be testing on that front. So I'm going to share this video. This one's a little bit longer. It's about 7 minutes where I'm actually going to test stuff. But this one's cool because I actually find bugs. So you'll see what happens here.
Awesome.
So that's how I have it overall. Do you want me to run through a test case? I'm fairly convinced that this will work, but I can run through a test case really quick.
Yeah, can you run through that test case real quickly?
Sounds good. So remember when I just told you not to say, I'm pretty sure this will work? That was a mistake I just made. And spoilers, my code does not work. And Sam knew that before I said anything. So me saying I'm pretty sure this works just makes me look like a damn fool. So don't do that. The first thing that we're going to do, so let's take 3, 2, 4 and the target as 6. So let's go ahead and say 3, 2, 4, and then 6. So first thing we're going to do is call makeDict. So this is going to call makeDict on 324. So let's make a new dictionary, and then we're going to iterate over this. We're going to iterate 3 times. I equals 0 to begin with. If it contains nums I. So if it contains 3, which it doesn't, so I'm going to keep track of all my variables and comments here. So it doesn't contain it. So we go down here and we say dict nums I. So nums I is 3. And then we're going to set the value equal to 0. And then that's inside of an array. Cool. 2 is going to go, so next we're going to make this I equals 1. If it contains that, it doesn't. So again, we're just going to do something like that. And we're going to do the same thing here. Let's say that we had a 3 here let's just test out our code. So if we have a 3, then it's basically going to go through, and then, so now we have I equals 3. If dict.contains nums I, which now it does contain it, then we say dict nums I dot append. So dict nums I is 3 basically, is 0. So we're taking this value and then we're appending I to it. So we're going to have something like this. So I'm convinced that this function works. Do you have any questions about that?
Yeah, that function looks good.
Okay. So let's keep going. I'm going to delete these comments and clean it up. And so now we have this dictionary. And, so now that we have this dictionary and it looks something like 3 to 0. Oh, I have this dictionary up here. So the dictionary looks good. It's what we expect it to have. Then we say for I in range, so we're starting at 0, I equals 0. And curval equals this thing. Okay, so this is going to be 3 to begin with. One thing that we haven't done is checked whether we're using the same number twice.
Exactly.
Yep. So one thing that we want to do is we can basically check if it's in the dictionary, but we want a second check. So inside of here, we also want to check and I not equal to dict remainder. So something that looks like that. So now if we run through it, we should see like it's not going to reuse 3 twice, and then it's just going to pass through this check, and then the next time it's going to go through and check the rest. So just to prove it, we'll just go ahead. Like now we're going to see 6 minus 3, so the remainder is going to be equal to 3. We don't see 3 in here with a non-zero index, so we don't have to worry about that. I guess there's a little bit extra logic that we want to do. Instead of I not equal to dict remainder, we want to check we want to check that dict remainder has a non-I value inside of it, basically. Does that make sense? You see my logic? Okay. So I'm going to go ahead and make a helper method for that. And dict has non-I value. And then I'll just go ahead and pass it this. So here's another example of me being like, oh, cool. I'm just going to define a helper method because this is really easy. It's just saying, does dict have this value? And if it does, return whatever we want. And basically, this is just going to return whether, let's just go ahead and not that. So basically, we're going to go ahead and check dictionary to see if it has a non-I value inside of it, pretty much. Do you want me to implement that? It's a pretty straightforward method, but we can implement it if you want.
Yeah, so you said it's just checking this dictionary to see if it has something that's not I.
Exactly.
Okay.
So not the dictionary, but pretty much the value of that key.
Okay. Yeah. No need to worry about that. That seems like a pretty straightforward function.
Cool. And I'm fairly convinced now if we get to 2, then it should go ahead and return 2, 4 inside of here.
Just one small hiccup. If there was another 3 in this input, right? So you had 0, 3. What are you going to return over here? Because dict remainder is going to be a list.
Right. Okay. So that's going to be a list. So we basically want to find the first value inside of there that doesn't have that isn't the value that we already had. So let's go ahead and we can change one more thing. Sorry about that hiccup.
Yeah.
Let's change this value a little bit. Let's change the return value of dict has no non-I value. Let's say get first non-I value from dict. And then this can be I dict remainder. And then let's say that this is index in dict. And then let's go ahead and this will basically, let's do it this way. So this function will either return none if no value is found, or it returns the first non-I value
Mm.
in the dictionary. And now we can go ahead and change dict remainder into index in dict. So now we're basically going to parse this array and basically check if there's some value in here that is not equal to I. And then if it does have that, then we're going to return that value. And then we're just going to store that. And then if there is no value found, then we'll just return none. And then if it doesn't exist, basically, so and this basically means that it's a non-null value. So if it is a non-null value, we can return that. Make sense?
Well, one other hiccup. If consider the case like where there's no x directory, right? So you want to return 2 and 4. Then if you're looking at 2, the remainder is going to be 4. 4 is in the dictionary, and index in dict would be, it would return 2.
Yep.
Okay, that makes sense.
Yep. Cool. So one quick question about that. So basically, like obviously I messed up a lot in there. There's two reasons for it. One is I am out of touch. I haven't interviewed for 4 years. It's been a long time since I've done a technical interview, and this was my first one in 4 years. I wasn't trying to make these mistakes. I wasn't acting. These were just literal mistakes I made. Hypothetical question, would you hire you if the interviewer made that many mistakes? I'm assuming you mean the interviewee. And yes, I think that was a passing interview. So we also did threesome later in that, and I would say that that was up to the bar of at least a weekly confident hire. Not necessarily like a strong hire, but I'd say a pretty good hire. The reason being that I showed my problem solving. Yes, I ran into mistakes. Yes, I made the mistake of being like, my solution works when it doesn't. And like, yes, Sam did have to help me through it. But what I was able to demonstrate was the fact that I was able to problem solve and communicate and be able to find solutions easily and elegantly when those problems were presented to me. Of course, it wasn't perfect. And the more perfect way to have done that would have been if instead of saying, I'm fairly confident this works, I would have actually found those bugs myself and fixed them all myself. But I started doing that and I still had other bugs, so it's not as big of a deal. Does that make sense, Mike? Cool. Now let's take your turn. Basically, now we're going to open up Zoom or Discord breakout rooms, preferably Zoom. You can go ahead and open up this HackerRank and pick a question. Basically, you can ask your partner if they want easy, medium, or hard, and then you can basically pick a question. Switch off and on mock interviewing each other. We have 40 minutes, so 20 minutes each, basically. It's okay if you don't like get through the entire question. I want you to focus on these skills that I was talking about. I don't want you to necessarily get like demotivated if you don't get the answer, but I want you to start running through your ideas. I want you to start communicating. I want you to validate your ideas by getting feedback from the interviewer. I want you to ask clarifying questions, and I want you to make sure you're writing pseudocode. So those are the things I want you to focus on. You should be able to do that in like 5 to 10 minutes. And then the other 10 minutes, you should be focusing on actually writing the code. Again, it's okay if you don't finish. I'll remind you at 20 minutes when we actually get to that point. So I'm going to break everyone into a bunch of rooms. let's go ahead and break rooms for okay, sounds good. So I'm gonna break everyone into some rooms, and here we go. Oh, people are dramatically dropping off right now. Okay, I'm gonna break everyone into rooms right now though.
Also meant to get an invite to breakout room 12.
Probably. Oh, did you want to moderate?
Yeah, I've had volunteered to moderate.
Okay, I will get someone moved to a different room then.
Sorry to whoever's in breakout room 12.
Yeah, it's all right. Josh or oh, sorry, not Josh. Ogedi, Rahman, or Divya, did you want to be assigned to breakout rooms? Doesn't sound like a yes to me. Okay, Simon, you want to just, oh, how do I let you?
I have no idea whatsoever.
Okay.
I don't use Zoom.
Yeah, neither do I, clearly. Okay, well, I don't know. I will just make you, I'll just throw you into random rooms. Sound good?
Sure. Yeah. 3-minute, 5-minute?
Sure, like 5 minutes maybe.
Sure.
How do I move you? This is so confusing.
Oh.
There we go. I got you.
Okay. Sam apparently has 3 people in his room, including him.
Yeah, that was on purpose.
Oh, I see. Put me in, coach.
All right. You're in breakout room 3 now. Did you get the
Yeah, I
invite?
can join. All right. AY,
did you want to be in a room? Okay.
He's just signing into HackerRank at the moment. Do you know what kind of difficulty question you want, or do you want to interview first, or do you want to be the interviewer first?
I think I can interview you first, definitely.
All right,
I
cool.
would probably do an easy. I even struggle with the easy ones right now. I'm
That's
terrible.
fine. Yeah, I mean, it's probably best to go with the easy one right now so we can practice the soft skills portion of
So-
it and not focus
which-
too much on solving the problem.
Yeah, I think that's a good idea. So I'm into the hacker rank. So which problem do you want to solve? For like your interview? Do you want to do an easy problem or like?
Yeah, let's do easy and you can pick whichever one.
Yeah. I think we can do like the first one, mini maxim.
Okay.
Okay.
I'm guessing I'm supposed to look at this because we don't have like a shared, or actually, can we share screens?
I think you can share a screen.
Oh, okay.
I think that's the way it's gonna work. I think you're gonna like share your screen, right? That's the way I think it works in a normal interview. You share your screen with the interviewer.
Yeah, they usually have like a software for that.
I think you
I
can.
think
There's like
Facebook uses like CoderPad or something like that.
oh, okay.
But yeah, hold on. I'm trying to share my Word document, but I'm so lost. Give me a second.
Yeah, yeah, sure, sure. Take your time.
Where do I do this? Oh, here we go. Can you see that? Or can you still see that?
The only thing it shows me is that you've started screen sharing, but I can't see your screen.